All right, as we know, okay, ladies and gentlemen, okay, again, I have a job. I'm just trying to do it. Okay, so with that, okay, part 1 is tomorrow, which you have that vocab that was passed back to you, that evaluation. Okay, so I would suggest that you look over that, but just because I suggest something doesn't mean that you may do that. I suggest that you look at it. You had to if I know I passed them all back yesterday. Okay? All right? So, some of the aspects that we have talked about in class, okay, might be as follows. Okay? So, when we talk about Newton's first, second, and third laws, okay, the first one deals with inertia, and that's kind of what this problem is dealing with right here. And the idea behind that is, as an object is moving on a curved path, is trying to resist that change in motion. We talked about on a racetrack as well. Okay? What that race car wants to do is go flying right off that track when it goes down a curve. Okay? That is inertia. It's causing it to move one direction or another. So any resistance, okay, any resistance of a change in motion, that is Newton's first law. Okay? And if you're watching this on a video or individuals here in class, if I keep looking down at this receiver, I'm just trying to make sure that the battery power is still on. So that's why you might see me looking down here, because I don't want to all of a sudden have the sound stop because the microphone ran out of power in the batteries. Okay, so that was Newton's first law, a resistance to a change in motion. Okay? In short, if you looked in your lecture materials or handouts that we did a long time ago before these projects, what might Newton's second law possibly be? It's actually an equation. It has something, it's similar to gravity.
An object won't stop unless it's like resistance.
So 1 deals with resistance. Second one. What about force?
An object will stay in motion.
Well, yeah, you're close.
Something about acceleration.
Right. That's why we write A for acceleration. So Newton's second law deals with mass times acceleration.
Is acceleration equals the net force divided by the mass?
Well, that's exactly what it is. This is just a shorter way of stating that. Okay? So then what a hunter might, especially pheasant hunters, okay, when you are talking about different types of sizes of gauges, for instance, when I first was introduced to pheasant hunting, the model of the number, it was just called a 410. I don't know what that means, okay? Some of you might know, because when we get to these different gauges, you've probably heard of a 20 gauge shotgun. Probably most common is probably a 12 gauge shotgun. You can even get down to 10. I don't know if they make anything.
Yeah, they make a 4 gauge.
Okay, I was not aware of that for sure. Okay, regardless. 20 gauge, 12 gauge, 10 gauge, 8 gauge, whatever. Okay? When you are doing something like this, okay, this is just a piece of lumber that was probably sticking down on the bottom of here, so we just cut that off. Okay? What does this maybe remind you of as far as a gun is concerned? The stock. Okay? So if you're holding this up against here, if you don't have that buttstock next to your shoulder when you pull that trigger, you're certainly going to know it. Why is that?
Because it flies back and it'll smack it.
Right. So it's going to, you pull the trigger, it causes that. Okay? So that is also another law of motion. It's not Newton's first law. It's not Newton's second law. It's Newton's third law.
Even if you hold it like this,
It's still going, yeah, even if you hold it tight, it's just not going to hurt as much. Okay? So that's Newton's third law. For one action, there's going to be an opposite reaction. Okay? That's Newton's third law. That's also part of your vocab terms as well. So we got action / reaction. That's probably the best way to look at that. For every action, there's an equal and opposite reaction. All right. No, I don't anymore because I think, metaphorically speaking, as I'm shooting, the pheasant would turn around and go, you missed. So, yeah. Anyway, the next diagram down that circle, that's not a model of the Earth. I just picked a point. How many of you, when you have a semi-trailer or any type of truck, what is behind those back wheels? True. It's probably a really, not foam rubber, really stiff type.
like a mud flap.
Mud flaps that are hanging behind those back wheels. Okay? Why are there mud flaps back there? Right. Okay? So if we have, for instance, in this case, made this up as an example, if this is a wheel, okay, and it's moving in this direction, we got this rock on a string, just looks like a wheel. Okay, and if it's moving in this direction, once it gets to the top, yeah, it's going to fly off if this rope breaks when it gets to this point here. But once it reaches that, we want to know what direction is that going to move then. That's what we're asking. Because of centripetal acceleration, if it breaks past this, notice what that force is doing. Is it going to cause it to go this way, or that way? So is it number 1, number 2, or number 3?
Between 1 and 2. It's 1 because it's going to be catching. No, it's 2. It's 2. 3. That's 2.
Someone finally said it. Number 3. It's going to go down.
How fast are you going?
I don't know. Yeah, I don't know. Okay? So now, if it's past this, the force is acting on it, going to cause it to go straight down. But if it breaks right at letter G, then it's going to be which one? Then it's going to be number 2. So it's kind of tricky in how you're looking at that. So that is why you have them mud flaps back there, not only just for the mud, but because of the rocks, and especially if you are a motorcycle rider. Okay? And it has happened before that you might see junk coming down the road, rocks, metal, anything else. If you're on a motorcycle, it's probably about like getting hit by a rifle shot, because that's going to hurt. There's something to that too. Yeah. Or you wear a helmet. Some of us sometimes aren't quite that disciplined. Yeah, that's where I say, do as I say, don't do as I do.
You ride a motorcycle?
I do.
What kind of motorcycle do you have?
I've got a Kawasaki Vulcan 900. Yes. Okay.
You ever drive it here?
I used to.
Why don't you anymore? Because the climate has changed, maybe?
Global warming
No.
is happening.
He said he used to,
No.
Fabian.
Okay.
Would you ride?
Is he good? Mr. Volker, do you ever ride her to Sturgis?
No. Would I want to? Yeah, sure. I'm sure that's fun. Now, we're looking at different types of friction. Okay? Your desks right now are in contact with the floor, and they're not moving. they're not going to move until you apply enough force to actually overcome the friction on there. So if it's not moving, that is static friction. So that 0 means no net movement. Okay? And then what would you guess is a type of sliding friction then?
Like this.
Right. Once you have enough force to overcome that, you're swaying back and forth on your table. That is sliding friction when two objects come in contact with one another. Okay? And I distinctly remember this talking about in class. But parts of this we didn't. Does anyone ever heard of the 7 ancient wonders? What different historians are going to have different lists, but an accepted value of the 7 ancient wonders of the world, the oldest and only one that still exists is the Great Pyramids. Okay? So the precision that was put into that type of a design and architecture is actually quite phenomenal, because we are looking at about how many years? Is it maybe 4,000 years and they're still standing? Okay. And it's believed that you can't slide a piece of paper or you can't slide anything in between these two blocks, just because of the mathematical precision is just that. It's so precise. Okay. So one of the things we talked about is when they built those pyramids, there's a quarry perhaps not too far away. It wasn't very efficient to get the quarry rocks from point A to point B because of this here. They did. Okay, I hope I caught that soon enough. Okay, there are 4 forces. Okay, protons deal with the strong force, neutrons with the weak force, and then electrons for the electromagnetic force. Then the 4th one is gravity. Okay, gravity is what causes weight in an object. The further you get from the earth, the less you're going to weigh. All right. So, now, if I was to fold this like so, okay, and if it was plastic instead of cloth, and then we got this here, typically what would hold? What would hit the ground first? Why is this going to hit the ground first before? Say that again about resistance. Okay, this has less air resistance. This has more air resistance. Why is that? Because it's got more surface area.
Because if you throw that outside on a windy day, it's probably going to fall.
Yeah, it's going to fly away. That goes back to your 4-wheeler and your snowmobile. Okay, that's why people wear snowshoes, right? When you spread that out, you spread the weight across. You're not going to sink in. Now, should you be unfortunate enough to be out on a frozen pond, for instance, why do you not want to stand like this?
Might slip.
True. You can fall in. All that weight is on however far your feet are apart. It's all on this amount of square inches, if you want to call it that. But if you, rather than being like this, what happens to the amount of area when you lay on your side like this? You spread all that weight out amongst this surface area as opposed to standing like this.
How are you supposed to stand? You're supposed to lay down.
Well, we're not saying you're supposed to stand or not, but
Doesn't your head weigh a lot?
yeah, it does. That's why some of you people might have neck problems, because we're sometimes sitting on our cell phone and we're looking down like this. That's hard on your neck to do that. Okay? I'm guilty of that too. Okay? And then for those of you, if you are, let's say, throwing an object, okay, and it's over a very long distance, okay, what type of path is this going to follow? Is it going to go perfectly horizontal like this?
It's gonna end up going.
Why is it, you're right, why is it doing that? Why is that path curved?
The momentum and the gravity is taking it down.
The higher you throw it, the more momentum it's going to catch air.
Well, that's true, but it's always going to be curved. Now, what would happen if you didn't have any gravity on that and you gave that a fling? Like, it's just going to keep going straight. There's nothing acting upon it. Right. Okay. So now, this is a problem. You're making a comparison. Okay? The 47,000 is something you're only comparing it to that. Okay? Because sometimes this can get to be a problem. Maybe it's with a runaway train. Okay? It maybe came unhooked from the locomotive or something to that effect. These have a very large mass, and once they get going downhill, if it's going around a curve, it may just flip off of the side. Okay? And sometimes that can even happen with operator error as well with a conductor going around a curve as well. Okay. So regardless, you've read the problem. It says a rail car with a mass of 6,600 kilograms was moving at 24 meters per second on the top of a hill. If a little over 3.5 seconds later, the car is moving at 49 meters per second. If the car reaches 47,000 newtons, it's going to flip over the next curve. Okay? Will this happen according to these numbers? That's what you're going to try to calculate. You've read the problem. the very next thing you should do is what? Okay, so what do we know in this problem?
The velocity.
The mass is.
Final velocity and initial velocity. The mass, the force, the mass is
And the time. The time.
Okay, now, remember, we are comparing to this. So, if that is the case, what two things do you need to know to solve for force?
acceleration.
Acceleration and mass. Well, we've got the mass, which is what?
VI and VS.
Okay, 6,600 kilograms. Okay, what is 49 meters per second? Yes, it's a velocity, but which one? Okay,
Can I text Donnie and ask him to
no, please don't. Okay, what's the initial velocity?
I believe that buddy.
What's the time then?
3.47 seconds.
Okay, so now you correctly said we need this to find the force, but we also have to have the acceleration. We don't have that.
But you already got your final velocity and your initial velocity.
But you can solve for your acceleration.
So what you're going to want to do is
You're gonna take away the
velocity
final velocity
and subtract
minus
your initial velocity.
and divide it by your time.
Divided by your
And then you
time.
get
25.
And then you get your
I know why it's not and then you'll figure out your answer.
Times 6,600, which is going to be 46,075.
Okay, if I'm not mistaken, your acceleration is about 7.10 meters per second squared. Does that sound correct?
Yes.
Okay, that's one.
Times 6,600. That's going to give you 46,875.
0.00.
I don't know what it is precisely. In this,
So that's exactly.
according to this problem, is that car going to flip? No, it's not going to, because it didn't quite reach 47,000.
It was close though.
It may have been close.
Could have been on 2 wheels, do you think?
It might have been on 2 wheels. I don't know.
Four because there's 8 wheels on the that's
Whatever, doc. Okay. But it still could have been on.
Okay. Questions over this?
No, sir.
No, sir.
Okay.
Problem. Got her locked in.
I think we should study the vocab.
Okay. Is there anything else? Tomorrow it's too late. We are. But what I'm saying is that portion is tomorrow. We probably don't have time to work on this. That's why I say tomorrow's too late. Yes?
Can we do like a game for vocab to study?
Well, you can make up your game. I don't know.
Right now?
Yeah, make it good.
We don't like that. No, you don't.
Yeah, you love it.
Oh, yeah, well, you might, but other people don't. It's free points. We don't like free points. All right. Can I erase this?
You like liking men?
Yeah, he likes trying to make the paper ball.
We literally said your name. I believe that means we're directing our work.
Let's go, Brandon.
That's inappropriate.
Okay, sound is still working. Okay.
Hey, I have a good question.
Put on TikTok.
I have a good question, Mr. McKinney.
Well, yeah, maybe you do, but we're not concerned about your good question that you think is a good question. I appreciate the enthusiasm.
I asked everybody.
What's that stand for? The New York Yankees?
NYPD. Kentucky Fried Chicken.
New York.
New York.
Yanks.
Kind of like a nickname, okay? The Yankees may sometimes be referred to as something bombers.
No, I'm done watching baseball. The Yankees suck. This year.
Have they won a championship?
What about the Padres? Did you know Padres is actually father of Spanish?
Did you know no one asked?
You know,
No, he didn't.
that's for
I like the red shirt.
I had to take this idiot to 34 before. Get it right, skin. I got one for the post.
Oh,
Mr. McKinney, I like the red shirt today.
Why, thank you.
Lombardi Trophy.
he actually asked.
Thanks. Why do we do that?
I was just guessing what it was.
It's an easy question.
No good.
Oh, it's an easy question. Bro.
Wait, why did I say next year?
Come on now. He spent a long time thinking about that one.
Yeah, that one was hard. I would have never gotten that one.
First God ever.
Can you do who is Lombardi? Who's Brandon?
Oh, yeah.
Well, how about we just stop at one? If we don't like my questions, we just won't have them.
No.
Son,
I appreciate
shut your mouth or I'm gonna
the
kick you.
extra credit.
It's not fair.
Girls, calm down. Calm down. This is real life situation. You're gonna have to deal with some men in your life.
Who has it?
Right, Caitlin? Oh, Caitlin, you said she's been dealing with a guy for about a year now. It's just a couple of
Okay.
facts that haven't been dealing with that. It's glasses, yeah, it's glasses. Chris, I haven't told you what to think.
Like, for instance, if we were to say the artist Old Blue Eyes, that was Frank Sinatra. It was just a nickname for Frank Sinatra, Old Blue Eyes. So when we talk about a reference to Bruce Springsteen, he may be called the blank. Okay? So I'm trying to make a correlation with that.
So we have to find his real name.
Bruce Springsteen is his real name, his nickname, right? And if we don't like my questions, I'm sorry. They're bonus questions. If you don't like doing them, don't do them. All right. If you have any questions, what can you do if you are struggling with these problems?
Ask for help.
You can come in and ask for help. We're available for you to come and help. Before school, after school, anything to that effect. All right? But that takes responsibility. That is for you to do. You need to take that initiative. All right? No other questions? Now, the goal behind this is this opens up a line of communication between you and your parents. But I don't know. Maybe if you talk to them, great. If not, I don't know. That's not my control. All right. We'll catch up to you next time.